Hi Geometry, this is Unit 5, Lesson 13, page 605 in our workbooks. So let's take a look at these two solids. First of all, I can see that the base is 20 by 32, so it's not a square. So this first figure I know is a rectangular pyramid, because it goes up to my point. So all the cross sections are rectangles that are getting smaller, where the original one would have a scale factor of 1 all the way up to the point at the top where my rectangle doesn't exist anymore and my scale factor is 0. These cross sections go for a height of 25 centimeters. So then this is an oblique. We learned this word the other day. An oblique cone. My base is a circle with a radius of 7 and goes all the way up to a point. My stack of circles that are getting smaller and smaller and smaller go up for a height of 10 feet, a perpendicular height from the top of my cone to the plane on which my base sits. So it says for each solid, draw and label a prism or cylinder that has the same base congruent to the solid and height equal to the solid. Let's do that on the top. I'm going to use this bottom blank area to actually do the volumes. So on top, the prism that would go with this pyramid would have a rectangular top base and would have a rectangular bottom base. It's not really drawn to scale. This does not look like 20 versus 32, but we'll draw it like it is in the picture. And then I would attach my vertices, and this would be my prism that would have the same bases as my pyramid, and it would be a stack of rectangles, 20 by 32 all the way to the top. And over here, I would have a circle with radius of 7, but I'd also have another circle with radius of 7 on top. And you could draw this oblique if you wanted. I happen to just draw, I imagine my circle being something like this, and then I just drew my but it doesn't matter if it's oblique or not. And my height would be 10. Going back to A, my height would be 25. So those would be the prism and cylinder that would have a base congruent to the pyramid and the cone. So let's take a moment and calculate the volume of the pyramid and the volume of the cone. So I know the actual volume of a pyramid is 1/3 big B times the height. And so in this case, my big B is a rectangle. So my volume for my pyramid is 1/3 of my length times my width, that's my big B, times my pyramid's height. So then I know that my volume is 1/3 of, and you can put them in any order, 20 times 32 times 25. And so I would grab out my calculator. If you multiply the 20 by 32 by 25, you get 1,600, or 16,000, sorry, all divided by 3. So then you could divide by 3 on your calculator, and you would get 5,333.3 repeating. This answer can also be written as 5,333 and 1/3. And you can also think about, instead of dividing by 3, going back up to my second to last line, you could think about multiplying by 1/3. You can do that on your calculator by doing 1 divided by 3 equals, and then you could do times 20 times 32 times 25 as well. Come to office hours if you need any help with that. So that would be the volume of my pyramid for A. Let's do the volume of my cone for B. We also know the volume of a cone is 1/3 the area of the base times the height. So in this problem, the volume of my cone would be 1/3. My base is a circle. That's my pi r squared times the height of my cone. So now when I put in numbers, my radius was 7 and my height is 10. So by PEMDAS, you should do exponents first. So you get 1/3 pi times 49 times 10. And you can, when you do this math, multiplying, you can actually write your answer to this problem in quite a few different ways. So I want to show each one to you. So if you see it, you understand the answer, and you also understand your options. So first of all, we're just going to multiply all my numerators. You can think of the pi being over 1, the 49 being over 1, and the 10 being over 1. So pi times 49 times 10 would be 490 pi in the numerator, and 3 times 1 times 1 times 1 is 3. So you could write it in this manner. Some people put the pi out to the side, so you might even see it written as 490, like a fraction, over 3 pi units cubed. Both those are the exact same thing. You're just taking 490 times pi divided by a 3. So then another way to do this is to think of the 490 divided by 3 and to do that on your calculator. So some people might write that 490 divided by 3 as 163.3 repeating. So some people might write this as 163.3 repeating times pi units cubed. The 0.3 repeating is equal to the fraction 1/3, so you might even see this written as 163 or 163 and 1/3 pi units cubed. Or finally, if you did 163.3 repeating times your pi, you get 513.13 units cubed. No pi in your answer because you've multiplied by pi. All of these are popular ways, if you will, or correct ways to write your answer. None are more correct than any of the others. For me, I am more likely to write my final answer by multiplying by the pi, just being done with it, or not doing any of my multiplication because I'm not really using my calculator, I'm just doing it in my head. So the very first answer, or if I'm going to get out my calculator and start dividing, I'm probably going to leave it as a final answer. But anything in between would be an okay way to leave your answer as well. And a little bit of practice and some time to process this, and you'll be more than fine with doing this type of problem as well. So page 606, I'd like you to take a look at these diagrams on your own time. I want to say this is similar to on page 602. We looked at 3 square pyramids fitting into 1 cube. So in this picture, notice that you have a triangular prism in the picture, and this is 3 triangular pyramids that if I put them together, if I could assemble them together, they would equal the one up above. Again, it's trying to reinforce that the volume formula for a pyramid is 1/3 times your base area times your height, because it would take 1, 2, 3 pyramids to fit into your prism. So take a look at this page 606 on your own time, please. Okay, so taking a look at page 608, please. Let's take a look at activity 13.3, comparing our cross sections. So it says each solid in the image has a height of 6. So I know that all of these have the same height. It says the base area for each solid is 10 square units. So let's look at this blue base. I have a triangular base, its area is 10. In my rectangular pyramid, its area is 10, and in my cone, the area is 10. So if you remember, we did a similar activity with prisms. The idea, the volume is the same. If my base area is the same, and my height, so if my big B is the same, and my height is the same, then my volume will be the same. So we've already kind of looked at that process before. So continuing on, it says that there is a cross section created in each by using the base as the center and a scale factor of 0.5. So you can see, let me get a different color here. You can see if I cut into my different shapes, I would have my cross section, and this is a cross section where my K is 0.5. Because remember, in each of these, I begin with my K equal to 1, and I have my cross sections all getting smaller and smaller up until my scale factor is 0, and I no longer have my base anymore. My triangle has went to a point. So it says calculate the area of the 3 cross sections. To do that, I have to go back to earlier in our unit when we learned that the image area is equal to K squared times the original area. So if I'd like to find the little yellow cross-sectional area, then my area would be equal to, and I've run out of room, so I'm going to write it to the side, my image area for those, my image area would equal my scale factor of 0.5 squared times my original area. My original base area was 10. So I would put 0.5 squared in my calculator times 10, and I get 2.5 units squared. So the area of this yellow triangle is 2.5 units squared. The area of this yellow rectangle is also 2.5 units squared. And the area of this yellow circle is also 2.5 units squared. So it says, suppose a new cross-section was created. So they cut it somewhere else. For example, looking at my yellow triangles, the smaller one or the bigger one. And it says, how would the areas of these cross-sections compare? Well, if they cut the triangular pyramid, the rectangular pyramid, or the cone in the same place, they would be the same. The area would be equal, and you could calculate it because the image area, like we wrote above in number 1, is simply equal to the scale factor times my original area of 10. 3, what does this information about cross-sectional areas tell you about the volumes? Well, since these 3 shapes have the same cross-sectional areas, for the same height, then that again tells me that they have the same volume. And then it would like me to calculate the volume of each solid. So my volume is 1/3 big B times the height. In this case, my big B is 10 times the height of 6. So that would be 60 divided by 3, so 20 units cubed. Look at the next page. So taking a look at the homework pages, the practice pages on page 610, I'd like to talk about number 2. Number 2 says that a cylinder has a radius of 9 and a height of 15. A cone has the same radius and height. So for A, it says find the volume of the cylinder. So my cylinder has a radius of 9. So my radius equals 9, and it has a height of 15. So I know that the volume of my cylinder is the area of the base times the height, and the base is a circle, pi r squared h. So I know that it would be pi times 9 squared times the height of 15. So let's put 9 squared into our calculator. We get 81. Let's multiply by 15. I could write this answer as 1,215 pi units. In this case, it's inches, so inches cubed. I could also multiply by pi. If I multiplied by pi, I believe it is around 3,817.04 inches cubed. So for part B, it says define the volume of the cone. My cone has the same circular base with a radius of 9, and it has the same perpendicular height of 15. So my volume formula for a cone is 1/3 big B times H. So for a cone, it would be 1/3 pi r squared. Sorry about that. Pi r squared times the height. So we're going to substitute in 1/3 times pi times our r squared times our height of 15. So on this problem, this is one of the ones where we can leave our answers in lots of different forms. So first of all, 9 squared, 81 times 15 is the same 1,215 pi that you got above. So I could write this answer as 1,215 pi over 3 units, which is my inches cubed. So this is one way to leave my answer for my cone. Another way is to go ahead and divide 1,215 by 3. And I would get 405 times pi. Don't forget your pi here. I have not multiplied by pi yet. I only divided my two numbers, my 1,215 in the numerator by the 3 in my denominator. And I would get inches cubed. Or I could multiply by pi. And if I did that, multiply by pi on your calculator, I would get 1,272.35 or 0.3 or 0.34. Rounding does not matter to me. Inches cubed. All three of these answers would be a great answer for this problem. Personally, I probably would leave my answer in the second form, but I think all three are great. They're all correct. Any of them would be fine. Thank you.